So for example number 2, we're going to find the arc length, and that is an actual length, and that's just a portion of the circumference. So if I have a circle, and that circle has a radius, and we measure from one part of the circle to another part on the circumference, like say from here to here, like this is point A and this is point B, we can measure just this part right here, and that would be the arc length. Now that's a portion of the circle. So remember that a circle, if I go one full rotation, that's 360 degrees, or it's also equal to 2 times pi. So if you notice in our formula for circumference, we have 2 times pi. Well, if I don't measure the whole 360 degrees, I'm measuring a portion of it. So then the relationship, or the math that we're going to use, is that the arc length of A to B. Now before we measured it in degrees, right? And that was just based on the central angle, but now we're actually going to measure it in like centimeters, like figure out how long that is if I take a tape measure and measure along that curved path. Whatever it is, it's divided by 2 times pi times r. Okay? So that would be equal to the measure of AB over 360 degrees. Because 2 pi is one full rotation. In other words, this is the circumference. So the portion of it is this over 360 degrees. Now, another way that you could look at that is that you could say the measure of the arc length, this probably doesn't make any sense. It will when we plug some numbers in. So the arc length of AB is equal to the measure of the arc AB over 360 times 2 pi r. So what they did is, the difference between this formula and this formula is this one. If you take this formula and multiply both sides by 2 pi r, it cancels on this side, but then you have the 2 pi r on the other side. And so we use this information to calculate the arc length of AB. Okay? So then let's do some examples. So for example number 2, if I have this circle here, and I have the center P, and I know that this is 8 centimeters, okay, and I measure 60 degrees. The way that this works is, I'm going to say the measure So let me clarify this too, because Mr. Adams, even as a math teacher, I accidentally used these differently. This is the measurement of the length in units, like centimeters, inches, feet squared. This is the measurement based on the central angle, and that's in degrees or in radians. Well, this is always in degrees. Okay, so if I want to find the arc length, and we'll call this A, and we'll call this B. If I want to find the arc length of the arc from A to B, then I need to write down the measure of AB according to its central angle, which is 60 degrees, over 360 times 2 times pi times the radius, which the radius is 8 centimeters. Like that. Okay? So now what happens is, this is 1/6 of the circle, right? Because 3 360 is the full circle, and 60 is 1/6. In other words, this fraction here will reduce down to 1/6. And then 2 times this would be 16 pi centimeters. And then if I multiply this together, I get 16/6 times pi centimeters. Now that, if I divide the top and bottom by 2, I get 8/3 times pi centimeters. Okay? Now if I plug that in a calculator, if I say 8 divided by 3 times pi, I'm going to get 8.38. So we did all that work to find out the length of this. So, in other words, I could calculate the entire circumference of the circle based on this. Whatever that is, I would divide that by 6, and then I would get that this measurement right here is just going to be 8.38 centimeters. Now we're dividing by 6 just because of the proportion, right? So we started with a proportion, and then we did a little bit of the legwork to kind of get a formula that we could use. So let's do a different example of this, because there's more than one application. Let's consider another circle. And we'll call this X, and we'll call this Y, and we'll call this Z. And I know that the central angle is 40 degrees. And we're given the arc length of 4.19, and we're asked to find the circumference. So we're still going to basically have the same thing. So we're going to start with the arc length of XY is equal to the circumference. That's what this formula, the 2 pi, so the arc length over 2 pi r, this is the same as the circumference, right? Is equal to the measure of xy, that's referring to the central angle, over 360 degrees. Now that's a proportion, okay? So I happen to know that the arc length is 4.19, so I'm going to say 4.19 centimeters. Oh, actually, that's in inches. Over the circumference is equal to the measure of this angle, which is 40 degrees, over 360. Now, this reduces down to 1/9. If I divide this by 40, I did that in my head, that equals 1, and if whatever I do to the bottom of the fraction, I got to do to the top. And then I get 4.19 inches is equal to C. So we solve this by cross multiplying. 9 times 4.19 inches is equal to 1C. Well, we're just going to call this C, and then if I say 9 times 4.19, it's kind of hard to see there, I get 37.71 inches. And that's basically it. I've got one more example. Consider a circle that looks like this. And we're told that the length from here to here is 15.28 meters. And we're told that the arc length from here to here is 44 meters. And they want us to find the measure, basically the central angle, from R to S. So the measure is in degrees, but when I say arc length, when I use the word length, that's in whatever units. So this is the arc length because it has the units. So the way that I solve this is I'm going to set up my formula again. Arc length of RS, okay, and that's equal to the central angle that we don't know. That's what we're solving for. All over 360 degrees. And then over here we're going to say 2 pi r. So the arc length is 44 meters. All over 2 times 3.14 times 15.28 meters. Now notice that the meters cancel right off the bat. And then I got the measure. This is the central angle, right? This is the same as the central angle. In other words, your answer should be in degrees. All over 360 degrees. So then, if I plug all this in, if I say 44 divided by, and then you got to put it in parentheses, 2 times 3.14 times 15.28, close the parentheses, I get 0.4585. So this whole fraction becomes 0.4585, and that's equal to m, the measure of RS, over 360 degrees. So now what I need to do to get this 360 away, because I'm solving for the measure of RS, I'm going to multiply both sides by 360 degrees. So these will cancel, and then I just take this number and multiply it by 360, and I get 165.07 approximately, and that's in degrees. And so what I've done is I found this central angle. This central angle is 165.07 degrees. Okay?